Now, let us solve part A using method 2. Method 2 is what we are calling the principle of perpendicular lines. Perpendicular line. We shall apply the concept of perpendicular lines. So, part A, we are given the equation as x squared plus y squared equals to 5. And the point of tangent is negative 2 and 1. Here it is very important that we sketch the circle to guide us. So I'm going to draw the circle. I assume this is my tangent from a given point B to the circle. What is the point of tangent given? The point of tangent, I'm going to call it A, is given as negative 2 and 1. We know that the center of the circle is in the middle here, and we have the radius, which is perpendicular to the tangent. This is the tangent. Now, in method 2, it is important that we get the coordinates of the center. If you look at the equation here, the coefficient of x squared and coefficient of y squared both are positive 1. So we can use this equation the way it is. Now, what are the coordinates of the center in this equation? The coordinates of the center are 0 and 0. 0, 0. Please go on and compare it to the expanded equation, or compare it with the factorized equation, and you get the coordinates of the center as 0, 0. So let me say this is center C. Now, the radius is going to be root of 5 units, but the radius is not important to us. What is important to us is the gradient of the radius, because we know this is the radius R, which runs from the center up to point A. It is a line, so we need to get the gradient of the radius, and then we apply the concept of perpendicular lines, because the radius is perpendicular to the tangent, so that we can get the gradient of the tangent. So let us get the gradient of the radius and know that it is a line. Now, we have 2 points, which is the center and the point of tangency A. These are the endpoints of the diameter. Sorry, these are the endpoints of the radius. So we can use the endpoints of the radius to find the gradient of the radius. So I'm going to use point C, 0, 0, and the point of tangency point A, which is negative 2 and 1. When we use those 2 points, we shall get the gradient of the radius, because it is a line. We know that gradient M is given by changing y, which is y2, minus y1 into x2 minus x1. This means that, let's name them, this is x1, y1, x2, y2. So we substitute for y2, it is 1 minus 0, out of x2 is negative 2 minus 0. That is the, yes, this here gives us negative 1 out of 2. Okay, we are getting negative 1 out of 2. That is the gradient of the radius. After getting the gradient of the radius, what do we know? We know that the radius is perpendicular to the tangent. Is perpendicular to the tangent. What do we know about 2 perpendicular lines? We know that the product of the gradients of 2 perpendicular lines is negative 1. That means M1 times M2 equals to negative 1. This is the gradient of the first line times the gradient of the second line. If they are perpendicular, they give us negative 1. So let me call the gradient of the radius m1, so that this is my m1. If I substitute here for m1, this means that I'm going to have negative half, which is m1, okay, times m2 equals to negative 1. Now, what is the value of m2, which is now going to be the gradient of the tangent? If you make m2 the subject here, you find that m2 is positive 2. Okay, is positive 2. So positive 2 is the gradient of the tangent. Therefore, gradient of the tangent is positive 2. It is positive 2. Now, if you know the gradient of the tangent and you know one point on the tangent, then you can find the equation of the tangent. So, for us to get the equation of the tangent, what do we need? We just need one point on the tangent, which is the point of tangency. It is for both the radius and the tangent. That is negative 2 and 1. And then we have our gradient m2 as 2. Now, we are going to use the formula for equation of a straight line, which is given by y equals mx plus c. Okay, where m is our gradient 2. You can call this x and this one y. The first coordinate is always for x. So let's substitute for x, y, m so that we get c. Therefore, this means that my y is 1 equals to my n is 2 times x. What is x? X is negative 2 plus c. Now in this case, what is the value of c? If I take this one to that side of the equation, I will negative 4. So my c is going to be 5. This is the y-intercept. Therefore, the equation of the tangent becomes y equals to 2x plus 5. So, this is the answer when we are using method 2, which is the concept of perpendicular lines.